Respected teachers, myself Prof, presenting you from the final sem on the topic of water quality monitoring system, which is our final year project, and we will be implementing and upholding on this topic. So what are the outlines that we have discussed or we will be discussing in this project is the introduction part and what caused us or what motivated us to take this project. Then comes the literature review. Then will be the problems identified and the methodology used. After that, the problem formulation and how we upholded with those problems and we approached towards the output of those programs. Then comes the block diagrams, which will be the necessary system models for which the whole of the system will be working and all of the system will be implemented on. Then the hardware components that will be required. Of course, this will be followed by the simulation process as we will be doing all of these hardware components in the simulation of the PROTEUS that we will be discussing in the upcoming slides. Then comes the circuit design of it. Then the work done that we have already did and what are the simulation and its results. Then we'll be comparing the data that we got from the universal data that all of us know about the water quality. Then the conclusion that we deducted from the output and what are its implications in that further review. Then the future works that can be done with this project, and of course the Gantt chart that how we had followed this project and the list of references. So starting with the introduction. So what it's like, the water pollution is one of the biggest fears in the globalization of the green globalization. So because many of our people are starving and most of the diseases has been caused due to the bacteria and most of the algae that has been found in an impure water. So what will be it if the present scenarios, if it goes on, then there will be a huge loss of health for not only for this society but for the whole of the country. So in this final year project, what we did is that we presented a real-time monitoring system of the Arduino UNO. As we know that we can also test the or we can also test it with the manual labor work, that by taking the samples of the water and just by checking it with the litmus paper and all, but that takes a huge time and also a labor cost is another problem. So by using the Arduino and by taking it to a whole new level of the real-time monitoring work, we'll be doing it, and it will also reduce the labor cost and also the problem of taking the samples and testing it in labs can also help be to reduce it. So the motivation. So what motivated us is that as we know that the economical and effective use of the water in the society is very essential. May it be a housing society or may it be the quarters that we are living in. So due to the high population, there are very fewer water resources, and for which we have been caused many troubles for it. So we all know that many of the water barriers or water reservoirs are also being polluted in India, like from seconds to seconds, as we can say, from the rivers like Gangas or Brahmaputras. They are always flooded with the debris and all the impurities that has been always indulged in them, and this has become a very massive and populative and highly impurities leading to the water. So what we'll do is that we'll take Arduino and of course we'll implement it with the checking of the impure water. So we'll take the Arduino UNO and it will be the basic of the project by using it, and also the GPS model which will become in the later half. So we'll deal with that the later. So these are the literature reviews that we'll be working on and which will help us to help with this project and how to approach the project. So starting with the author's name, these are the author's name and the work done that the authors have done. So from the first author reference, we got the working of the PH module and the Arduino. As we all know, the working of the Arduino model UNO, it's quite fine, but the PH module, it's quite complex, because when we integrate it with Arduino, so what happens is that the module doesn't quite directly get the voltage and directly gives the pH value, so we have to calibrate it. So how the calibration is done, I will explain it in this next slide. And from the next reference, we got the data acquisition and calibration. As I told you that those datas and calibrated, and after the calibration, how we'll get those datas. So we have to put down and jot down those datas, and we have to put it in the results, and finally the output will be shown. In the third literature review, we have seen the integration of different components of that made B. So our main components that we'll be holding is the UNO and the pH in the first half. Then in the next phase, we'll be dealing with the GPS module that will be giving the location of the present scenario of where the water is being impurated. So that will be afterwards. And the last one, the last literature review gives the GPS module of integration of how it will be calibrated with the Arduino UNO. So we'll be dealing it with an factor of latitude and longitude, and how it helps us to pinpointing the desired location. So the problems identified with this projects are after going through and performing all this, so we have identified the two problems. So first one will be the accuracy of the pH sensor. So the pH sensor is not accurate to its utmost as of now, but it can be done. So because it is not the utmost, because it will be suppose when we are checking it, so it needs to be calibrated more often than we require. So after calibrating, it comes to an accuracy. So it will be of highly accuracy if we calibrate it after every few seconds. So that is a problem with that, and unable to purify, as we are only checking the purification of this water. It's like that, suppose if we are in a housing society, there is a tanky, and all of the people from it take the drinking water, or which is the very necessity of this society. So what it does is that it only, if it will check that okay, this water is pure, and it will after checking it will just tell the municipality or the authority by the GPS location of it, that will be deducting it with the GPS location, that whether the water is pure or not. So after that the municipality will come, and they will check upon the impurity of water. But it is not like that they will purify those water. It's not like the total chemistry here. It's all different. So what are the methodology used? I'll be explaining in a step-by-step process. So the first, the system design is upon the Arduino UNO and mainly upon the GPS module. Of course, the pH sensor is there, and we'll be integrating it with the Arduino module. So there are two basic parts. So the first one is hardware, and the second one is software. So working with the hardware, the part sensor will be used to measure the real time will be the pH and the Arduino. So as we all know that the Arduino works on the C language, so we'll be encoding it those formulation and those algorithm, and after solving it with the trial and error methods, we'll be implementing it, and we'll be deducting it in the C language. And after we did that, we'll be calibrating the pH module. So the two works both hand to hand. So now after the calibrating of the pH sensor, we'll get a desired value. Then we'll check that whether the desired value is matched with the universal values or not. If it doesn't match, then we'll try to get the offset values. That was one that I was explaining about the accuracy of the pH sensor. If we do check it in an like cyclic process, then we'll get the accuracy, but it will be highly of accurate. So next we'll be going through, after checking, we'll be implementing it in the PROTEUS application that is in the PC. So it's a software that it's like it checks and it shows the output according to the components that has been uplifted and uploaded in the software. And the code, yes, that the code will be generated by ourselves. We will write the code and the algorithm, and we'll be deducting it. After this, the final step would be to concerned authority that the location contaminated it within the GPS module. So here this is one of the best step, as it's if someone housing society is like being contaminated, and he or she will not know how to check it, and if the water is in fact pure or not. So by doing this, we can not only check it, but also we can contact with the authorized municipal of the water to come and make the water clean, or to make the society a better place to live with a good water. So the problem formulation, how we got to proceed it with this project, was to calibrate the offset regulation of the pH probe with the required voltage. So it means that first there was a first we took the pH, and that it was a very difficult to that difficult to make the offset to its required voltage. So by making the voltage to its required probe, we needed trial and error method. That was our first step, because the pH sensor will not directly show the pH. It will show the voltage and the voltage corresponding to the pH. So that was our first aim. Then the next was to set up the pH limit. Suppose there was a pH limit, we all know that 0 to 14, with 0 being the acidic and 7 the pure water, that we all know. 7 to 7.3, it may be 7.4, and the rest is the alkalinity. So by setting it the pH limit of the module, we wanted it to the pH to function properly according to its required voltage. That was already explained in the step 1. In coding the GPS module was also one of the hardest part in it, because in coding the GPS module, we took the utmost care to find the location, to find the correction of the latitude and longitude of the society where the water is being impure. In the so this is the generic block diagram where it has been explained that the pH sensor in the left part, as we can see, the pH sensor connected to the Arduino board, as well as the turbidity sensor. So here the turbidity sensor is to check the turbidity of the water. Suppose there is we all know that the water is pure, okay, so the water is totally holding pure, but there comes the term turbidity, because there may be some suspended particles, very microparticles, which are not visible to our naked eyes, but this sensor, they are able to detect it. So if the pH sensor, suppose it gets a pH of 7.2, 7.3, so that's okay for the pure water, as we all know. But what about the turbidity of it and the suspended particles that has already been attached to it? So for that, we'll be using the pH sensor and the turbidity sensor by hand to hand. And then comes the GPS module, as I have already explained, to check the location of the Arduino UNO board along with the GPS module. It gives the location of the society or the municipality of that area. So the pH sensor will give the pH of the water, as from the right hand side we can see that, as well as for the turbidity sensor and GPS module for the area of the location. So that those three will be displayed upon the output of the LCD screen. As it is not necessary, or it is not even possible to always take a laptop from Arduino and to see whether those the pH of the water is alright or not by taking an laptop and checking it in a serial monitor. That is not even possible. So what we'll do, it will connect those outputs in an LCD screen. So what it does is that it will show the output in an LCD screen, and after showing the output, it will display it. So it becomes in very handy, as because before taking a water from a filter or some reservoirs, we can check the purity of water by looking at the LCD screen itself, whether at that time the water is pure or not. So this is the step of calibrating the voltage level, as I was saying. So by starting, I want to say is that from starting the loop, and the second part was to select the analog pin. By selecting the analog pin was because, as the pH module, it comes with an module where you have to connect the pH probe to this analog module. So the analog module in the Arduino may be any pin. It can be A0, A2, A3, any pin of it. Then we'll assign a variable to the analog pin. After assigning that variable, we'll convert that analog reading. So what was the required to convert those analog readings? Because the analog, after we all know that the VDD, that means the voltage that the Arduino board will be supplying, it will be the 5 volt. So it will be not in the analog form, so we have to reduce it to its analog form by converting it. Then after converting the analog form, we will be printing the voltages. So after printing the voltages, if the calibrated of the offset is not desired of the voltage, then we'll start the loop again. So what means is that, suppose we all know that the pH of water is 7 volt, 7, the pH of the water is 7. Then but in this pH module, by default, for pH of 0 volt, the pH of 0 volt, the pH is equal to 14 point something. So that will not be hold, because we want by default we want the pH to be of 2.5 volt. So if I explain it in a basic sense, it will be mean that if the pH in the probe, that will be of 7 volt, it implies that the voltage is of 0 volt, but it cannot be possible, because if suppose for some reason the water is acidic, then what we will do is that if the water is acidic, it will go to suppose 1 to 2 pH. So it will imply that the voltage is being in the negative form. So it cannot be happen, because the voltage cannot be in negative. So for that reason, we have to calibrate it so that the pH of 7, it deducts a voltage of 2.5 volt. So we'll be dipping the pH probe in the water, and after dipping the water in the water, there will be the output of the voltage, and as long as the output of the voltage doesn't comes to be 2.5 volt, that will represent the 7 of the pH. We'll be changing the probe, because if it comes in the alkalinity or in the acidic form, it cannot be it. But by changing it to an 2.5 volt, we can ensure it that the code is correct. So after obtaining the 2.5 volt, that is our desired voltage obtained, we'll be ending our program. So next comes the process of calibrating the pH. In calibrating the pH, suppose we took pH of a glass of water, then we'll dip the pH in that glass of water. Then this is the algorithm that the flowchart will be proceeding. So we'll start a loop. And after in that loop, we'll divide it in 2 sections. First, we'll get a samples of 10. So we took an average of 10 samples. It can be more. You can take it 20 to 30. The more you take the samples, the more accuracy you will get. But always there is a case that the more you take the samples also, it will take a little bit of time. So for that, we take 10 samples of it. Then in another loop, we are just sorting those samples. After sorting and getting those samples, we sort you can sort it in as well as in ascending order or descending order. We sort it in just an ascending order. So after sorting it, we'll take the average of the 6 center samples. We took this center samples because it defines, or it gives the proper result of it. If for 10 samples we took like the 6 samples of the average, but you can also take for 20 samples, you can take 12 samples from the middle. So it depends upon you. As I have said, the more you take, the more accurate you will get. So now we'll convert those analog into millivolts. So what was the need to convert it? Because before going to the pH, we have to convert it, those samples in the millivolts. As there are 6 samples, so first what we'll do, we'll convert those analog into the voltage that I have already explained in the earlier slides. After taking it analog to the voltages, then we'll convert it to the millivoltages of averaging of that 6 samples. Then after converting those, we'll display it, will convert to the pH. Those millivolts will convert it to the pH by algorithm that we'll be using. Then after that will comes the display. So here what we'll do is that we're displaying the pH of the water or whatever liquid may it be. So if suppose after displaying it, the pH comes out to be 8, then it will run the loop again, and the loop will continuously run, and it will keep on displaying the pH. And after that, if you want to like stop the program, then you can stop it at last. So this will be these are the hardware components that we are taking. First we are taking the UNO Arduino, as it gives a basic idea of the real-time work that we are doing, and it is an open board source, so it is a very easy and upliftment module to be working with. Then we'll take the GPS module. So this is the PROTEUS GPS module that we'll be using here. It is also that the Wi-Fi module, we can say. Then we'll be taking the pH sensor, after then the turbidity sensor. So this is the basic circuit design. I mean, this is just the basic circuit design of the pH sensor and Arduino. So here we can see that each of the Arduino is connected to the module of the pH module. So as I have told you, one of the module will be connected to the analog pin. So here the analog pin we took is A1, so we can take any analog pin, and another is the ground, and the another is the 5 volt. So that was the requirement to change it to from analog to direct the voltage, so dividing it by the 5 volt. So that was the basic need of it. So the work that has been completely done in this session of this final year was to the calibration of the pH sensor to its desired voltage. We calibrated the pH sensor to its desired voltage. As I have told you, by default the pH sensor comes to be from representing the pH 7, it represents 0 volt. That is the default. It is set by the company manufacturer of the pH sensor. So by calibrating here, I mean we calibrated the 7 to the 2.5 volt, not the 0 volt. Then we collected the samples and storing in an array. Here the array means the collection of values that we already discussed in the flowchart of the pH, where we saw that the pH is being collected and it can store the 10 samples. So you can take it at 20 samples or 30 samples. Then we averaged those collected samples and got the desired voltage. Then after those, the conversion of this millivolts into the pH, and finally the location of the water and via the GPS module. So this was the experimental setup. As you can see, the pen-like structure that has been shown, it's nothing but a pH probe, and it has been connected to the pH module, and which is connected to the Arduino. So here we can see, so this is the circuit simulation of the water quality. So here we have already seen that the LCD, we have already discussed that the LCD will be connected and the output will be shown in an LCD screen, so as it becomes very handy for the user. So here we can see that for water quality 4.1, it is showing the acidic, which is correct. Same goes for the pure water. Here the pure water, comes out to be 7 and near across it with the pure water. Then comes the alkalinity, which is beyond 7. It can be 8 to 9 to anything 14, so it comes out to be correct. So this was the turbidity. So the turbidity is measured is NTP. So it's the unit of this turbidity. So the required for it was to check whether the suspended particles was present or not, even if it is an pure or impure water. For this we took the pure water and we found that yes, there is some turbidity in it. And finally this is the GPS setup for which we took the help of the GPS module, as we can see. So here we can see it gives the latitude and longitude. It gives the accurate and the correct results as we go on further and further. Depending on it, it gives the accurate results. So these are the results that we deducted for 10 samples, and it is not actually for the 10 samples, but it is for 10 into I would say 10 into 10, but that is the 100 samples we are taking, and for that we are averaging for each of the samples and we got a data sheet of it. So in the left hand side we can see the practical, and the right hand side there are the normal. So from here it is seen that this is like the code is being run properly. So these are the serial monitor output that has been obtained for pure water, and then we tried for cold drinks. First initially we tried for the pure water, then we tried for the cold drinks. So this is the data comparison check, where the blue bar diagram it's constant as because it's the universal value of the water, that is 7. Then there comes the pH real of it. So with the pH real we can see that although the graph is going up and down, but it's fluctuating between 7 to 7.4 as so it's almost it's the correct form of the graph. From the conclusion part, we can all say that this project was to check the impurity, and we deduced and we uplifted the project with those impurities of water, and we checked it, and we found that the project is found to be in validity with those. And we can also further take it to the next step by checking the water quality and the of the big factories of or any industries, as it requires a very low cost and does not require any people on duty, because it is a real time, and it will keep on working it on an on process. So after the water is being tested, we also took the accuracy of it, or we can take the time complexity as we define it by the term. So by the time complexity we can see that the project this requires it is a very fast and it is a very convenient one. So the project holds a very good flexibility. So the future work we can do is as I have told you, from the big industries, or from the hydraulic industry, or from the air pollution industries, or the agricultural production units. So as for that example, I would like to give you a few examples of it. Suppose there is an radioactive reactor, so those reactors debris and all are being junked out in the water for most of the time. So for for uplifting those necessities and the taking those steps, we can also check the impurity in those areas also. So in the future of this project also, we can say we can purify the water if we take a sensor that purifies that has the ability to purify the water, then we can take it in a whole new level. So this is the Gantt chart that we have deducted, we have worked upon this the whole year, and as we have deducted it in a project domain, the project we have selected, then the literature review, then the study of the hardware components. For most of the parts we have studied with the pH sensor, it is one of the vital components. Then comes the GPS module, then the code. For the code we deducted it it can be detected in the trial and error method. So we have trial and error, and we found a proper algorithm for it. Then comes the data results and the simulation from the components. So these are the list of references that helped us a lot during this making of the project. So that's all. Thank you. So this is the PROTEUS design part that I've told you about the simulation process. So we'll be using the software to check the impurity and the purity of the water. So this works in a very simple process, as we have seen that for the water we'll be first using it in an analog pin. So we are using it in an A1 pin as we have deducted it. So then the output that will be calibrated, and the output is being calibrated. That code I have already set in this Arduino board. So after calibrating it, the output will be presented in this LCD monitor. So this LCD monitor, it presents the output for suppose like for pH of 7s, it will show acidic and vice versa, and also it will take those readings and it will probably show it. So by running it, we can see that this shows the output of the water, so whether it's pure or not. So it varies from one voltage to another. So if we check it from an accuracy, so it will be showing upon from 7 to 7.8, and again from 8.8 to 7. So these are some of the samples that has been shown, and it will continuously be shown in an LCD screen. So after that, I would like to show you the GPS module that has been integrated with it. Coming next to the GPS module, so we have used same software that we've been using it for the pH sensor. So in this simulation, what we did is that we took an Arduino, and this is the terminal. That the black box that you're looking is the terminal, and it's the virtual terminal that it will give us the longitude and latitude. We can say it's the location showing terminal. And so the terminal RX, that is the receiver output, is being pointed to the transceiver output of the Arduino board, as it will receive the data. So it will transmit, and that board will receive its output in the receiver section. So this is the GPS module. In the GPS module, the TX of that pin is connected to the RX of the Arduino. So the TX is the transmitter. So if the location of the impurity of the water is checked, so it will directly transmit it to the Arduino, and the Arduino board will receive it. And after receiving the Arduino board, it will transmit it as the people can know. So after running this code, you can see here it's the water quality monitoring, and here comes the latitude and longitude of the location or of the area where I'm staying in, and this will give the proper and whole address of the location in the Google Map. So this was the end of the project, we can say.